Dear viewers, welcome to another video in our playlist of time series analysis. In my previous video, I have explained about how the autocorrelation function need to be calculated for a time series with a lag of 1, lag of 2, lag of 3. And by doing this, we can identify whether the time series have a autocorrelation among its own data point with a certain amount of lag. So that is what an ACF function will help us to understand. Those who have not understood about the concept of ACF, I would request you to kindly listen to the video that we have posted on how ACF need to be calculated. Now in this video, we are going to understand how the T statistic need to be calculated and how we need to interpret the results of T statistics once we complete calculating ACF, autocorrelation function. Let's get into the video. As I was explaining in the introduction, ACF, autocorrelation function, helps us to establish the statistical relationship between a time series data with itself with a lag of certain number of data points, and that lag could be lag of 1 data point, 2 data point. So this I have explained in my previous video. So those who have not seen that video, I request you to kindly listen to that video before proceeding further, because what we are going to see in this video is once we have calculated ACF, autocorrelation function, how can we conclude whether the time series has a significant autocorrelation or not. So in order to do that, we need to do a T statistic calculation, and once we have this T statistic calculated, then we need to compare the calculated T statistics against the T critical value from the student T distribution. And based on what is your T statistics and what is the T critical value, if your T statistics value is greater than the T critical, what conclusion you will make, and if your calculated T statistics is smaller than the T critical value, what conclusion you will make. So that is what we are going to understand in this video. So before we go further, let me first explain you the formula. So if you see here, for us to calculate the T statistics for lag of 1, there is a formula which says your autocorrelation ACF function divided by standard error of your autocorrelation function. So that is the formula for lag of 1. However, if you want to understand the T statistic formula for lag of 2, 3, that is subsequent after 1, if you want to calculate the T statistical value, then the formula is slightly different. Here also we are dividing our autocorrelation function ACF divided by standard error for the autocorrelation function. However, the method of calculating standard error is slightly different, and if you see the formula, it says square root of 1 plus 2. Then it says you need to calculate the autocorrelation function, which is R2 or R3 or R4 depending upon how many lags we are doing, then summation of that divided by n, number of data points. So don't get intimidated by these formulas. We will try and break this formula as easy as possible for you. Let's get into the data example and try to interpret these formulas. So here we have the autocorrelation function already calculated for our time series data that we have used for our ACF video, which is nothing but the weight of goods imported in a port in hundreds of tons. So 43.200 tons, so 44.800 tons. This is the data, and this is ACF with a lag of 1. Now how do we calculate T statistics for lag of 1? So here is the formula. The formula says, so let me make it easy for you to understand. So if you see here, the formula says the numerator will be the autocorrelation function itself. The numerator will be the autocorrelation function itself, which is 0.6796, and the denominator, as you see in this particular section, it is nothing but standard error of autocorrelation function, and the standard error is calculated by 1 by square root of n. So the formula is very simple. So we have the numerator, and once we have the numerator, the denominator will be square root of 1 by 10. Why square root of 1 by 10? Because 10 is the total number of data point in our analysis, and by that way we have reached the autocorrelation we have reached the T stat for the autocorrelation function, the calculated T stat value. So now this calculated T stat value need to be compared with the T critical value. So how do we do this comparison? So here I have made a simple explanation for that. So if you see here, if you want to know the T critical value, I have given the link of the table here. So that link I have also opened here. If you see here, you will have the T critical values. So from here, which T critical value we need to take, let's understand that. Let me go back to the Excel. So if you see here, our total number of data points is 10. So how do I calculate my T critical value, or how do I identify my T critical value? I need to subtract 10 with 2. 2 is nothing but 2 degrees of freedom. Then I need to go to the table and identify with 95% confidence with a level of significance which is 0.05. So that's why we are moving for a 95% confidence level for a two-tailed test. What could be our T critical value? The T critical value will be plus or minus 2.306. So if your T calculated value is greater than this plus or minus, so you can have plus 2.306 or you can have minus 2.306. If your T calculated value, if that is greater than 2.306, then you can conclude that the autocorrelation is significantly different from 0. Significantly different from 0 means there is a strong correlation. It could be positive or it could be negative, but there is a strong correlation. However, if this value is smaller than plus or minus 2.306, then the autocorrelation value is not significantly different from 0. Not significantly different from 0 means it is almost close to 0. And if it is almost close to 0, then there is no autocorrelation exists, or a very weak autocorrelation exists. Now if you come back and look at our data, we are at 2.15 and our T critical value is 2.306. So this autocorrelation with lag of 1 is not significant enough. That is a conclusion that we make. So now we have seen how we have calculated it for lag 1. Now we will see how to calculate it for lag 2 and lag 3 subsequently. And as you see in the formula is slightly different. It is not like how you calculate it for lag 1. The formula is slightly different. So let's see how we will do it for lag 2. Right. So let me now break this formula for your easy understanding. Again, what is our numerator? Our numerator will be the ACF, that is the autocorrelation function. So M16 will be my numerator. Whereas my denominator will be square root of 1 plus 2 multiplied by square of autocorrelation divided by n. So that is the formula. If I want you to understand the formula easier, let me go back to the formula sheet. So if you see here, square root of 1 plus 2, then you have summation of, so the summation is, now we are doing it for lag 2 only. However, if we have lag 2, lag 3, lag 4, then we need to add it. That's why we have put summation. Then we say autocorrelation function square divided by the n. So in our case, we are doing it only for lag 2. So the function goes like this, which is nothing but numerator will be the autocorrelation function divided by square root of 1 plus 2 multiplied by square of the autocorrelation function divided by 10. And thereby we got 0.85. And we already know the T critical value is 2.3 and this is much smaller than this. So at a lag of 2 also, we do not have a significant autocorrelation. And now if we extend this calculation for lag of 3, right, that is to calculate T statistics value for autocorrelation with a lag of 3. If you go into the formula, you will understand. Again, the numerator will be the autocorrelation function itself. So Q16 will be the numerator. However, if you see the denominator, square root of 1 plus 2 multiplied by square root of the previous autocorrelation function, that is autocorrelation function of lag 2 plus square of autocorrelation function of lag 3 divided by 10. So if you see here the formula, let me go back to the formula one more time for your better understanding. Summation of, so as many number of lags you do, for all those number of lags you need to square the autocorrelation function. So that is what we are doing here. If you come back here, if you see the formula, we are first squaring in the denominator. First we are squaring the autocorrelation function for lag 2, then we are squaring autocorrelation function for lag 3. And similarly, if you are doing it for lag 4, lag 5, you need to continue to square it and then divide by 10. And as you see here, the T statistics value is still going smaller and smaller. And as it goes smaller and smaller, we conclude that there is no significant autocorrelation between, or significant autocorrelation in the time series, even for lag 1, lag 2 or lag 3. Friends, I hope this video was useful for you to understand how we can calculate T statistic value for a given autocorrelation function. And once we calculate T statistic value, how we can go back and identify the T critical value from the table. And once we know the T critical value, how we will be able to calculate the T stat, that is T statistic, and compare it against T critical and then make a conclusion whether the autocorrelation is significant or not. If the T stat value, calculated T statistics value is smaller than the T critical value, then you can conclude there is no significant autocorrelation. However, if your calculated T statistics value is bigger than your T critical value, then you can conclude that there is significant autocorrelation. So friends, I hope this video was helpful. In our next video, I'll be explaining about the Young box Q test value calculation, which will be again another test which will help us to understand, not only decide one particular correlation or autocorrelation, but to understand a series of autocorrelations with a certain number of lags. So that is what our Q test is all about. That is Young box Q test is all about. So I'll explain that in my upcoming video. Thanks for your time. See you in the next video.